Okay, hi Maria. Wanted to go through this code with you. Okay, so this is all fine. You load the data here. And let's use the debugger to see what's happening. All right. So I'll stop it here and let's run. Okay, so let's continue. All right, we reach here. So we have all of this, yes. So we're going through all of the place names. So name of place should be Bombascaro, which is the first one. I'm not sure why it's Bombascaro. It must have gone through the loop twice. So we're now in Bombascaro. Okay. And we have Zn and Xn and Wn. Let's see what we have here. If I look at Wn, this should be the weight of the birds in Bombascaro. So it looks like there are 8 birds in Bombascaro with different weights. And let's see what else we have. We should have Zn and Xn also. There should be 8 Xn. These are the point counts. So there are 8 of them. And then we have the transect observations. Okay, so it's fine. All right, now, so for each bird species, there will be a different Zn. And we want to generate a random number based on each different rate. So there's one random number with rate 4, one with rate 1, one with rate 2, one with rate 7, and so on. Okay. All right, so here we have the relative abundance. That's fine. I think we don't even use this, but that's okay. Okay. And so here we have the Poisson mean. Now, see, what you did here was you took the mean of Zn. Mean of Zn will give you a single number. Okay. That's not going to give me the different rates for the different species. That's going to give me one number for all species. Now your n should, I think you have n was 8, or no, all right, it says 9. Did I count the number of species wrong? Let me see how many species there are. Did I count the number wrong? Oh no, that's right, there's 9 because we start with 0. So very good, so there should be 9, that's fine. Okay, all right, now what you did here, if I take this, this will give me 9 numbers. But look at the size of these numbers. This mean is 46. So you're going to get numbers close to 46. All of your numbers will be close to 46. Okay. So if I do this, you see they're all close to 46, all close to 46, all close to 46. You're generating 9 numbers from the same distribution. So that's not what I want. I want to get if I put Zn here. See, I have 9 different numbers, and I want 9 different numbers from 9 different distributions. So instead of this one here, what I want is this. And I should just be able to put Zn like this. If this doesn't work, then we will see what happens. If I do this, you see it's giving me 9 numbers, but now these 9 numbers have a different distribution. This number 6 is close to this 4. This number 5 is close to this 1. You see, so I'm generating 9 different Poisson rates. Okay, so that's what I'm doing here, right? So you can see that this is different from how you had here. These are all very close to 40. Okay, so that's the difference there. All right, so now we want the transect operations. Let's see. I think this one should not be Z. I think this one should be X. I want to do a X. Let's see. Do we have X somewhere? Looks like there's no X here. So this one should be Xn instead of Zn, I think. Or no, all right, you did that here. Well, I'm a little bit confused. I think that No, that's right. Z is the one you should do this way. Then X is the one you should do the other way. All right. So let's look at X now. X is this number here. So what I want to do is generate the rate for X. And I need to think about this for a minute. Okay. Should be proportional to a Z times the weight to P. And you have that correctly here. So this rate is proportional to this. But we also want this, we also want the sum of the rates to be equal to the sum of the original X. Okay. All right. Now the sum of the original X would be sum of Xn. Okay. All right. So this rate here is very good. But then this is proportional to the correct rate. This one is proportional to the correct rate. Now here you have rate over sum of Zn. What this is going to do is it's going to make the sum of the rates equal to 1. So for instance, if I go down here, so let's just continue. Okay. So let's look at RT. Let me look at RT. Okay. Now, if I look at this one here, okay, if I look at that, is it going to copy for me? Okay. All right, so these are the numbers. Let's see. So what's the sum of this? Maybe this is right. Let's look at sum of these numbers. So this bit should be equal to the sum of the original x's. Okay, so this is 14. So I want sum of xn. Okay, so that's not quite right. I want the sum to be equal to the sum of the original x's. So so you're dividing by the wrong thing here. Here you have RT. To make this equal to the sum of the original x's, you can take RT divided by the sum of RT and then multiply by the sum of xn. Okay, so let me call this A. Okay, and let's look at A. And then if I take the sum of A and I take the sum of xn, it should be the same. All right, so it's slightly different. So you need to have a different value here. This one is fine. So you're not taking a single number, you are taking n different numbers. So that's good. But the rate is not right. It should the rate should sum to the sum of the original xn's. All right. So instead of sum zn, so the normalization here is not quite right. Okay. Sorry, I speak a little bit quickly, but I hope you can understand. Okay.